In the previous video, we learned that there are two flavors of friction. We have kinetic friction. Kinetic friction acts when we have an existing sliding motion between two objects, and static friction acts to try to keep a sliding motion from ever getting started in the first place. So in this video, we're going to look at some demos which will hopefully help us deepen our understanding of kinetic friction specifically. Now, to start, you can see that I have a box here and a string connected to the box. That string is also connected to force scale. So I'm going to grab onto the force scale so that I pull the box along the tabletop in a straight line at constant speed. Okay, now look at the reading on the force scale as I do this. So I'm pulling the box along the tabletop in a straight line at constant speed. And I ask you, what is the net force on the box? Okay. What is the net force on the box as I pull the box in a straight line at constant speed, and my force scale is reading about 4.5, maybe 5 newtons? The net force is 0, right? Remember that when an object moves in a straight line at constant speed, the vector sum of all forces acting on the object is 0. So if we clearly have this tension force, let's say about 5 newtons, let's say we have this tension force of about 5 newtons pulling the box to the right, how is it possible that the net force is 0? Well, we must have some other force equally strong pointing to the left. Okay, what's that other force? Well, that other force must be a 5 Newton frictional force pointing to the left, and that would be a 5 Newton kinetic friction force, because in that experiment the box was in motion. So that reading that you see on the scale is telling you not only what the strength of the tension is, but as long as the box is moving in a straight line at constant speed, the reading on that scale is also telling you the strength of that kinetic friction force going in the other direction. Okay. Now, in that experiment I just showed you, the box is quite light. We'll ignore the weight of the box itself, but the contents of the box have a weight of about 20 newtons. And you can see that when the contents of the box weigh about 20 newtons, that gives us about a 5 Newton frictional force, a 5 Newton kinetic frictional force between the box and the table. All right, let's see what happens if we start adding stuff to the box. So now the contents of the box, about 40 newtons, and let's see if that changes the strength of our kinetic frictional force. Okay, so how about that? We doubled the weight of the stuff inside the box from 20 newtons to 40 newtons, and our kinetic friction force going back to the left doubled from 5 newtons to 10 newtons. All right, now what do you think is going to happen if I add stuff to the inside of the box so that the contents of the box now weigh about 60 newtons? Well, for 20 newtons of stuff in the box, kinetic friction was 5 newtons. For 40 newtons of stuff inside the box, kinetic friction was about 10 newtons. So for 60 newtons of stuff in the box, let's see. So for 60 newtons of stuff in the box, let's see. Right, so with 60 newtons of box in the stuff, with 60 newtons of stuff in the box slides along the tabletop at constant speed when the tension in the rope is about 15 newtons, indicating that the kinetic friction is, in this case, about 15 newtons. Okay, so let's recap. So with 20 newtons of stuff in the box, kinetic friction was about 5 newtons. With 40 newtons of stuff in the box, kinetic friction was about 10 newtons. And with 60 newtons of stuff in the box, with 60 newtons of stuff in the box, kinetic friction was about 15 newtons. So can we take away from these experiments that the weight of the box determines the kinetic friction force? It's tempting to say that, but it isn't really the weight of the stuff inside the box that determines the kinetic friction force. Now, to see why that is, let's do a couple more experiments. So I'm going to go here back to, actually, let me do it this way. So I'm going to go back here to having 40 newtons of stuff in the box. So that should be about 10 newtons of kinetic friction. Okay. But let's say then that without adding any stuff to the inside of the box, let me put on the cover, and I'll show you that even with the cover, kinetic friction is still about 10 newtons. Right? The cover didn't really change very much. Okay. But this time, let's say that as I drag the box along the table, I'm going to push down on the top of the box. Let's see what happens now. So when I drag the box along the table with me pushing down on the top of the box, you can see that the kinetic friction force went up by quite a bit. Okay, so I didn't change the weight of the box and I didn't change what was inside the box, but by pushing down on the box, I'm able to make that kinetic friction force go way up. Now that tells us that it is not really the weight of the box which is determining the kinetic friction force. It is something else. Now, what do you think that something else might be? Well, we're going to explore that in the next video.